Hello! Today we're gonna get started on the CSES problem set. We're gonna start with this first problem. It's called Weird Algorithm. We will be given a positive integer n and we have to do the following. If n is even, then we divide it by 2. And then if n is odd, then we have to multiply it by 3 and add 1. And we'll have to repeat this process until we get to 1. So we are given an example. If n is 3, then since it is odd, we're gonna multiply it by 3. That's 9 plus 1. So 10. Since 10 is even, we're gonna divide it by 2. So we get 5. 5 is odd, so we have to multiply it by 3 and plus 1. That gives us 16. And if you notice, 16 is a power of 2, so we're gonna keep dividing it by 2 until we get to 1. So this is pretty much it. We're gonna be given a number n up to a million, and then we have to output all the values it takes to get to 1. At a first glance, this process does not have to finish. It's not obvious that it's gonna end to 1, and this is a very well-known problem in mathematics. It's called the Collats Conjecture. It is an open problem in mathematics. We don't know whether or not any value of n would converge to 1, but it has been checked up to 2 to the 60th, I think. We're gonna say a word or two about that conjecture later. So let's look at another example before we get to code. As we said, we have this function f of n that is equal to n over 2 if n is even and is equal to 3 times n plus 1 if n is odd. As we said, it is not obvious that this process has to terminate, so we need to make sure that for our n, which can reach 10 to the 6th, we need to make sure that this process of getting to 1 does not take too long, which means that it cannot take more than 10 to the 7th operation, which is approximately the number of operations allowed in 1 second, and 1 second is our time limit in this case. So before executing the process and getting the values, we're gonna check in this range what is the maximum number of iterations it takes to get to 1. Besides from that, the code should be pretty obvious. We're gonna start at the given value and then we're gonna print it, move to the next value accordingly, and repeat this process until we get to 1. So let's create this program we mentioned. Let's call it number of iterations. So basically what we want is to find out the maximum number of iterations it would take to get to 1 from any value. So let's call this maximum value, maximum number of iterations, and we're hoping it is an int. It's gotta be an int, otherwise it would take too long to get all the values. So let's call it max iterations and initialize it with 0. So we gotta max it with all the number of iterations for all values of I from I equals to 1 to a million, to 1 million I plus plus. So we're gonna set max iterations to be equal to the max of itself, and the number of iterations it takes to get from I to 1. And in order to calculate that, we need to create a function for that. So let's call it number of iterations and let's create this function. So it should return an int number of iterations, and it takes an int as well. So what is the base case? So if I is equal to 1, then nothing is to be done, so we should return 0. Otherwise, if n mod 2 equals 0, that means n is even, then we need to return 1 plus the number of iterations of n over 2. That is because it takes 1 to execute this operation, and then we're left with our next operand, which would be n over 2. Else, if n is odd, then we would return 1 as well, plus the number of iterations of 3 times n plus 1. Why is this not working? Oh, I said here, so I should call this n. Doesn't matter. Okay, so all fine and dandy. Let's compile. Let's execute. Seg fault. Why on earth did that happen? So it seems like there is a stack overflow of some kind, but we're pretty much sure that the number of iterations does not get too large. But we did not check what would happen for n. See, if we get a strike of odd numbers for a while, then we're gonna keep multiplying by 3 for a while. And if that happens more than, like, say 20 sometimes, I guess 3 to the 20 some is larger than max int, so that would overflow int. So we better change this to long. And to make sure that this is the cause of the problem, let's check what is the largest value that n reaches. Let's declare a global variable. Let's call it long max n. Set it to 0, and let's max it with n every time. See what we get. And at the end here, let's print max iterations is max iterations, and max n is max n. See what this gives us. So this works. So the maximum number of iterations is 524, which is not that much. So the longest series of number or sequence of number we would have to print is 524 integer long. And the largest, and n gets up to, don't know how large this number is. So that's 56 billion. So it's 56 billion and some, so it's clearly larger than max int, so we gotta keep that in mind. So now let's go ahead and code the actual solution to the problem, and we'll do this next. So let's go ahead and code this problem. We're gonna start by reading the input. As we said, n might overflow, so we're gonna declare it as a long. We're gonna read this value. Then as long as n is different from 1, we gotta keep applying the algorithm. So first we gotta print this value with an extra space, and then if n is even, we're gonna update n to n over 2. Otherwise, n would be equal to 3 times n plus 1. And then at the end, we gotta print 1 So let's check it out. That seems right. Let's submit it. And it works. If you wanna see more cool stuff about Collats Conjecture, please stick around until the end of the video. So I went ahead and plotted the number of iterations it takes to get to 1, as well as the steps required. And one can't help but notice certain patterns. There are a lot of consecutive values that require the same number of iterations. For example, 12 and 13 both require 7 iterations. 14 and 15, they actually merge at 40, but 14 got there through 13, whereas 15 got there through 80. Another block of 2, another block of 2, a block of 3, another block of 3, a block of 5. So I would encourage you to check out the Wikipedia page for the Collats Conjecture. And if you did not know about this problem before watching this video and you end up solving it, please don't forget to mention my name in the footnote of your paper. I'd really appreciate it. So this is pretty much it. I'm gonna leave you with the animation of the whole range. And thank you very much for watching. See you in the next video. Thank you.